crazy professor invented a time machine. He sat in the seat of his time machine and pulled the lever back to go 1 million years into the past, to the Stone Age. He looked up and around. He encountered some cavemen. The cavemen were not very friendly to the crazy professor. So he ran away from the cavemen, very quickly sat on his time machine and pushed the lever to go forward in time, back to the present. But he pushed too much. So he ended up way past the present, hundreds of thousands of years in the future. And there, he encountered human-eating monsters that come from the ground. So he had to escape from those human-eating monsters as well. So he pulled the lever back and came back to the present. These are scenes from the novel Time Machine, written by, in 1885, who was it written by?
Einstein?
No, H.G. Wells. It's a fiction. It's a novel. I didn't read the book, but I saw the 1960 version of the movie as a teenager, many years ago, with my father. And after I saw the movie, I wondered, is time travel really possible? Is time travel to the future possible? Is time travel to the past possible? Will somebody invent a time machine one day? And using that time machine, can we travel in time? What do you think? I'm putting the question to you. Do you think that somebody will invent a time machine one day and we will be able to travel in time? What do you think?
No.
No. That's what my father said. He said, Rasih, I mean, this is science fiction. Travel in time like this crazy professor, this is impossible. But, he said, time travel is possible. I said, oh really? Tell me about it, Dad. And he said, he started saying, according to Albert Einstein's special and general theory of relativity. And he continued on for 10 minutes. And I was really, really fascinated. So I went up to my room and pulled out the children's encyclopedia. The children's encyclopedia was Hayat Ansiklopedisi, Arabic and Turkish, and it was explaining in very much detail Einstein's theory of special and general relativity. The more I read, the more fascinated I got. Einstein didn't talk about time travel. He didn't say it was possible, it was impossible, but his theory implied that it was possible. And I said to myself, as a teenager, it was the year 1971, wow, this is not a science fiction writer who's saying this. It's the greatest scientist ever, Albert Einstein. If the greatest scientist ever says this, it must be possible. What was he saying exactly? Einstein was saying that the great physicist Isaac Newton was wrong in assuming that space and time are absolute. What does it mean, absolute? Absolute means it doesn't change for anybody. No matter what speed you travel, no matter what you do. Einstein said no. Newton was wrong. Newton was wrong in assuming that space and time are different things. Space and time are not different things, was saying Einstein. There's one entity called space-time. And space-time can be stretched, it can be bent, and it can be warped. We all experience space-time differently, based on our speed of motion and direction of motion, and also based in the strength of our gravitational field, said Einstein. What does all this technical jargon mean? Well, it means that the faster you move, the slower time ticks for you. And the faster you move, the shorter space gets for you. And what Einstein was implying was that the special type of science fiction that we see, where an astronaut hops on a spaceship and travels close to the speed of light in space for 2 years, spaceship time, comes back to Earth, finds himself 500 years in the future, is not science fiction, it is fact, was saying Einstein. I was fascinated out of my brain, because it was not some kind of science fiction writer who was saying this. It was the greatest scientist, Albert Einstein, who was saying this. And what does it mean that space is not absolute? Well, think of it this way. Let's do a thought experiment. You fly from Istanbul to New York by plane. It's 8,000 kilometers. Now, suppose you fly on a spaceship close to the speed of light in space, 8,000 kilometers. Put the two 8,000 kilometers side by side, Newton would tell you that they're the same. But Einstein tells you that even though they're both 8,000 kilometers, the 8,000 kilometers of the spaceship is much, much, much shorter. In fact, it could be a fraction of a millimeter if we measure it here on Earth. Now, well, okay, but the encyclopedia that was written in 1969 or 1970, and I was reading in 1971, said that even though Einstein received the Nobel Prize in Physics in 1921, his theory has never been proved neither right or wrong scientifically. Einstein himself wasn't worried. When somebody asked if a scientist one day makes an experiment or observation that proves that your relativity is wrong, what would you say? And Einstein said, there must be something wrong with the experiment or the observation. I know I'm right. Nobody could design any experiment or observation that could prove Einstein either right or wrong. And would anybody like to guess why no scientific test could be made to prove whether time travel to the future is possible or not? Anyone like to guess?
Technology wasn't ready.
What's that?
The technology wasn't ready at the time.
Good! Yes, technology was not advanced enough when Einstein published the special theory of relativity in 1905 and the general theory of relativity in 1916, where he added gravity. And when Einstein died in 1955, it still was not possible to make any scientific observation and test, because we could not build a spaceship. We could build spaceships, but not that comes close to the speed of light. We could have just hopped on it, gone close to the speed of light, and if we travel to the future, Einstein was right. But there was another way to test. And that would be by testing if there is any time travel to the future, slowing down of time, which is the same thing, at slower speeds. For example, if you get on a plane at 800 kilometers an hour from Istanbul to New York, you travel in time to the future, according to Einstein's relativity. But only billionth and billionth of a second, because you're traveling much, much slower. We needed a clock that was so accurate that could measure if really time slowed down for the plane. But that was not possible. But all that changed. Only a few months after I read that encyclopedia, in 1971, it finally became possible to produce atomic clocks that could measure billionth and billionth of a second. Some two scientists called Haffel and Keating in the US, in the famous Haffel-Keating experiment, decided to test Einstein. They put one atomic clock on one jumbo jet, another atomic clock on another jumbo jet, and one atomic clock stayed at the airport in the US. The two jumbo jets took off at the same time. One traveled eastward in the same direction as the rotation of the Earth, and the other one westward, opposite the direction of the rotation of the Earth. They flew around the Earth twice. They landed. Now, if the atomic clocks on the planes showed were left behind the atomic clock on the ground, that would mean that Einstein was right, that time slows down with speed and we can travel to the future. If there was no difference between the atomic clocks on the planes and on the ground, then Einstein would be wrong. There is no such thing as time travel in reality. The world was waiting anxiously to see if time travel was fact or fiction, whether Einstein was right or wrong in the year 1971. What do you think scientists found when they compared the clocks on the planes with the clock on the ground? Do you think they proved Einstein right, that time travel is possible to the future, or do you think they proved him wrong? What do you think?
Right.
Yes. The clocks on the planes had slowed down But it's not the mechanics of the clocks that slow down. Time itself slowed down by 40 billionth of a second compared to the clock on the ground. Now, 40 billionth of a second may not sound like much, but it's enough to prove that time slows down with speed and travel to the future is possible. To make sure that there was no mistake in this experiment, scientists repeated this experiment many times on other planes, other scientists, and also on satellites that orbit the Earth at 14,000 kilometers per hour with respect to Earth. And every time they found that the clocks on the planes and the satellites showed that the planes and the satellites traveled a fraction of a second into the future. Time had slowed down for them. Who uses the GPS system here to find direction? Okay, the GPS system is one of the best proofs that Einstein's theory of relativity is correct, and that time travel to the future is possible, and time slows down with speed. Because the GPS system uses several satellites in orbit around the Earth, orbiting at 14,000 kilometers per hour with respect to Earth. And the clocks on the GPS satellites have to be continually synchronized with the clocks on Earth, because they fall behind the clocks on Earth by a fraction of a second. Now, who can tell me why the clocks on the satellites fall behind the clocks on Earth?
Different speed. Different speed.
Exactly, this guy's a genius. All right, okay. Now, yes, because if Einstein had been wrong, if time were not slowing down speed, if time travel to the future was not possible, there would be no need to synchronize the clocks on the GPS satellites with the clocks on Earth. A Russian cosmonaut named Sergei Krikalev is a record holder in time travel. Sergei Krikalev stayed in space 800 days. He is the human who has stayed in space the longest. Not in one time, several times in the International Space Station, orbiting at 14,000 kilometers per hour with respect to Earth. Scientists measured that Sergei Krikalev, time slowed down for him 0.02 seconds. So he traveled to the future 0.02 seconds. He is a record holder. That is still not much, but it still proves that time slows down with speed, and travel to the future is fact, not fiction. The only reason why we travel only a fraction of a second into the future, not hundreds or thousands of years, as we see in science fiction, is because the fastest we can travel at the moment with spacecraft is 40,000 kilometers per hour. Nowhere near the speed of light, which is 300,000 kilometers per second, not per hour. But one day, when we have the technology to travel much closer to the speed of light, we will be traveling hundreds of thousands of years into the future. There is one natural event that scientists observe, which also proves that time travel to the future is possible and time slows down with speed. It has to do with the subatomic particles called muons. Muons are subatomic particles that are formed in the upper layers of Earth's atmosphere, 80 kilometers high up. When cosmic rays hit the upper layers of the Earth's atmosphere, muons are formed. Muons' lifespan is very, very short. 1 divided by 200,000 seconds. They travel at 70% of the speed of light. They come down towards the Earth, 80 kilometers. If time travel were not possible, if time did not slow down with speed, if space did not contract with speed, the muons would not be able to travel all the way down, 80 kilometers down to the sea level. Scientists have detected a lot of muons at the sea level. They would vanish out of existence after 10 kilometers coming down. But they don't. They come down all the way 80 kilometers. Because when we say that their lifespan is 1 divided by 200,000 seconds, which time is that? That's our time here on Earth. But time slows down with speed for the new muons. As they travel at 70% speed of light, their life is much longer because time slows down for them. And also, space contracts, that is distance contracts, which means that when we look at the muon, we see them coming down for 80 kilometers. The muon also thinks that it's going down 80 kilometers. But the 80 kilometers of the muon is much, much, much shorter than the 80 kilometers that we measure. Now this may not make any sense, but if we think in absolute terms, in Newtonian terms, we don't see that one 80 kilometer is shorter than the other 80 kilometer. The observation that muons can reach down all the way to Earth, 80 kilometers, is another proof that time travel to the future is possible, that time slows down with speed. To wrap up, time travel to the future that was seen by science fiction writers, and that was implied in Einstein's theory of relativity, has been proven by scientific experiments and observations again and again and again. It's a fact, there's no question about it. And when we have the technology to travel faster, we will be able to travel hundreds of thousands of years into the future. But what about time travel to the past? Well, according to Einstein's general theory of relativity, that is also theoretically possible. But unlike time travel to the future, it has